Hello, hope your day is going well today. Gonna jump back into this lesson 7.4. If you didn't watch the first part of the video, go back and watch it right now before you get even more confused. All right, I hope this isn't too confusing for you. Please make sure to ask lots of questions if you have them, and I will do my best to get back to you in a timely manner here. All right, so we're working with similar figures still, but one thing that's in this lesson that is maybe new to you guys is something called the geometric mean. Okay, it's a different way of finding the average. So if you have two numbers a and b, you can figure out the geometric mean by multiplying them and taking the square root of them. All right. So for example, the geometric mean of 4 and 9, what we would do is take 4 times 9, which is 36. And so the geometric mean of 4 and 9 is the square root of 36, which is equal to 6. Okay. Now there is something that we usually use for the average called the arithmetic mean. Okay. And in that mean, you're adding the numbers, then dividing it by 2. So this is a different way of finding the average. And the geometric mean is often commonly used for when there's large variability in data, such as maybe the amount of people with coronavirus 2 months ago and the amount of people with coronavirus today. It allows you to compare average better than the arithmetic mean. So different type of mean. Okay, here's another example. This one, not so easy to get an exact answer for. Geometric mean of 3 and 9. So what we would do is take the square root of 3 times 9. Okay, so the square root of 3 times 9 is equal to the square root of 27. All right, but there is no perfect square root of 27. So you could approximate it with a decimal in your calculator, or what you could do instead, if you notice 9 is a perfect square, so what you could do is take and just think of it as being two square roots, square root of 9 times the square root of 3, and then you would simplify square root of 27 as 3 times the square root of 3, okay? So you can actually, if you notice the one number is a perfect square already, you don't even have to multiply. You see there's the 9 there. You just take the square root of 9 and pull it on the outside. It becomes the number 3, but you're still left with the square root of 3. Okay, so this is what they call in the book, if you see this on a couple of the problems, this is called reduced radical form or simplified radical form or something like that. Okay, so if they want you to simplify a radical, you have to take the square root of any of the perfect squares contained inside of that number. Okay, and then you keep the other number underneath the square root. So hopefully that helps you a little bit with that. All right, back to this idea of finding missing sides in these triangles, okay, that are formed by an altitude. Okay, so you have a triangle again has an altitude in it, and you have three similar triangles that are created. The one big triangle, and then you have two inside of it that are created. Okay, so we're looking for CD here, and it looks like we don't have a lot of information, but when you do have the hypotenuse and you have it like split up into two equal parts for, or not equal parts, but two parts for the two triangles that are inside of it, that's actually enough information to figure out the altitude, which is pretty cool. All right, so what we're going to do is we're going to use the two smaller triangles and not the bigger triangle, okay, in order to figure out the altitude. And so what you want to do is redraw the triangles so that you can compare them and they're orientated the same way, okay? So the one triangle I'm using, I'm just highlighting it in green here, is this one, okay? So I'm not going to take the time of redrawing that one. But this other triangle is flipped the other direction. And see, the smaller side is 3.6, okay? And it should be lining up with the smaller side of this green triangle here, which is DC. So I already took the time to redraw it. There it is, okay? So DB is now facing the same way as DC. So you always want to take the time to redraw these triangles first. Okay, now what you notice here is there is actually, if we're looking for CD, CD is in both of the triangles, okay? So we could just call CD x, or you could just call CD CD, okay, if you're setting up a proportion, okay? All right, so these two triangles are similar. So let's look at the proportion that you could set up here. All right, so they're comparing AD to CD, okay, so AD to CD, and that's equal to CD, okay, so that's the long, not the long part, but the height of the triangle here, okay, and they're comparing it to DB. All right, so they're going from green to black, then going back and doing green to black, okay. Now notice CD is in both ratios, okay, and it's actually diagonal of each other. So if you actually go and put the numbers in place of this now, so let's go ahead and put the numbers in place of this. That would be equal to, okay, AD was 6.4, so we'd have 6.4, and for simplicity, I'm just going to call CD X, okay? X on the bottom, and then you have X on the top, and the other one was 3.6, okay? So now this is where you might recognize, okay, if you multiply X times X, you're going to get X squared, all right? 6.4 times 3.6, guess what? This is like the arithmetic, not the arithmetic mean, but the geometric mean, okay, the one that we were talking about. 6.4 times 3.6 is equal to, my calculator just broke on me. All right, let's try it again. It's equal to 23.04, okay? And then, to figure out what x is, you have to undo x squared by taking the square root of both sides, and so you can approximate what it's equal to. Square root of that, it's going to be 4.8, okay? Actually, that's exact, so you didn't have to approximate at all. All right, let's look at this other one here, very similar. I want you guys to take a second and try to figure it out. You can pause the video. All right, so hopefully you were able to figure this one out. If you didn't notice, I already redrew the one triangle that is not facing the same way as this other triangle, CDB, okay? So this green triangle I redrew over here just so it lines up the same way, so it's easier to write the proportion here, okay? So DC, which is the longest side of this triangle, actually the longest side is AC, which is the hypotenuse. But DC, which is the second longest side of this triangle, is the one we're looking for, and it matches up with DB, which is the second longest side of this middle triangle here. So in our proportion, we could say x over 15. Okay, now if you did 15 over x there, that's okay as well. Or if you started out with the 5 and put it over x, that's fine as well. Okay, there's different ways you could set it up, but you'll get the same answer in the end. So 5, okay, so we went from little to big, so we're going to go from little to big on this one. So it'd be 5, okay, which is the smallest side, gets them compared to the smallest side of the other one. So 5 to x, all right? And so it looks kind of similar to the last problem. You're going to do cross multiplying. X times x is x squared. 5 times 15 is equal to 75, I believe. Yep, and then we're gonna actually put this one in simplest radical form. So you might have gotten the decimal version of it, but square root of 75 you can split into the perfect squares of 25, and 3 isn't a perfect square, but 25 times 3 is 75. So if you want to put something in simplest radical form, you always want to pick one of them to be a perfect square, the other one won't be. So this would be 5 square root of 3 in simplest radical form. Okay, we're not going to worry about part B, but here's a hint over here. If you're not sure like which triangles to use in a problem, you want to pick the triangles. If there is a missing side, you want to pick the triangles that both contain a missing side. Like I didn't want to pick the biggest triangle because that didn't contain the missing side. All right, let's look at another problem. But before that, the corollary talks about the geometric mean. The length of the altitude compared to the hypotenuse is the geometric mean of the lengths of the segments of the hypotenuse. So when it says segments of the hypotenuse, it's talking about AD and DB, okay? So you can figure out the altitude by taking the geometric mean of the segments of the hypotenuse. Okay, so in other words, CD is equal to the square root of AD times DB, which is a neat little thing. You could figure out the altitude by the geometric mean of the hypotenuse. So if you keep that in mind, it will help you on some problems. This example is a little different. You're trying to find the bottom of the triangle, RT. Okay, so once again, the same question. Use the two triangles that both contain the missing sides. You have three triangles you could pick from. Which two triangles do I want to use? Well, you don't want to use the smallest triangle because it doesn't contain RT. So this triangle is kind of out. So let's use the given triangle here, okay? Now, we don't know the total hypotenuse, but we can figure that out by simply adding. So sometimes that's good to do. Simply add these two together. So the hypotenuse total is 15. And that's good to do if you're going to be using the big triangle. And in this problem, my plan is to use the biggest triangle because that contains RT, but also this medium-sized triangle which has RT as its hypotenuse. So let's take this triangle that I tried to draw in purple and redraw it to be the same shape. Okay, so we have, it will look like this. RT is going to be the hypotenuse of it, so we'll have R and T here. Okay, and then we would have UR as the base of this triangle. So UR is here. And there you go. So we know UR is 9.6. Okay, we're looking for RT, which is the base of this triangle. So we could call that X. Okay, for the one we're looking for. We're looking for the base of this triangle. That's X. And do we know the hypotenuse, which is RT? Let's think about that here for a second. Okay, so the hypotenuse, which is RT, is also X. Because RT, the base, is the hypotenuse, which is interesting. So now let's see if we can write a proportion that would make sense to solve this. Okay, so let's first compare the hypotenuses. So I'm going to go from the small one to the big one. So we would have X over 15 is equal to, we're going to go compare the bases. Now we went from the small to the big. So we're going to do 9.6, which is the small base, and the big base is X, which is, all right, so now look, we can do the geometric mean again. Okay, multiply the diagonals, we get X squared, X times X, and 15 times 9.6, which is a big number. All right, 144. All right, and hopefully you know the square root of 144 is just equal to 12. All right, so that's it for that one. Okay, this one, you're trying to figure out JL and KL. Figure out JL and KL. So, I want you to pause the video and take a second to figure this out. Okay, I hope you got the same thing as I did. For JL, you want to take the small triangle, flip it so it's oriented the same way as the big triangle, since they both the small triangle and the big triangle are sharing JL, okay? You do cross multiplying and you get x squared equals 96. Simplify it, you get 4 root 6. For letter B, you're trying to find KL. Now, KL is in the medium-sized triangle, not the small one. So I redrew the medium-sized triangle to be the same way as the large one, okay? And then Y is the hypotenuse in the medium one. And it is the base in the large one. And so there's my proportion. I cross multiplied. I got 480 equals y squared. Simplified it down and then split it up. I got 4 root 30. All right. Hope that helps you with this lesson. And you guys have a great day and talk to you soon. Bye-bye.